This is a solution to problem 2.5.5, one of the homework problems in week 2 of Math 470. In this problem, we want to show that the sum of the first n integers, in other words 1 plus 2 plus etc. plus n, is equal to n times n plus 1 over 2. We want to show that this is true for all natural numbers n. This is set up perfectly for induction. For induction, we need to do two things. First of all, we need to show that the formula is true for n equals 1. Second, we need to show that if it's true for n, then it's true for n plus 1. I've said that in kind of a shortcut way. Officially, we would say if it's true for n equals k, then it's true for n equals k plus 1. But why introduce another variable? If it's true for n, then it's true for n plus 1, should be relatively clear to understand. If both of those are true, then we can conclude that this formula is true for all natural numbers n. Before we just jump in and try to prove this, let's see if it works, at least for the first few natural numbers. The sum from 1 to 1, that's 1. If we put in n equals 1 into the formula, we get 1 times 2 over 2, which is 1. So yes, the formula works for the sum from 1 to 1. Below that, I've tried out the formulas from 1 to 2, 1 to 3, and 1 to 4. In each case, when I add up the left side and I evaluate the right side, the two results are equal. That's good. If the two results were not equal, then this formula wouldn't be true, and we would have wasted a lot of time trying to prove something that wasn't true. So now that we've seen that this formula is true, at least for the first few n, we're a lot more optimistic that it actually can be proven for all n. We've already shown that it's true for n equals 1. It's equal to 1 on the left side and equal to 1 on the right side. So you see, induction problems usually start off very easily, showing that it's true for n equals 1. Now we need to do the inductive step. We assume that it's true for n, and then we need to show that it's true for n plus 1. Now that we've finally gotten to the proof, it's actually pretty quick. We assume that it's true for n. In other words, the sum from 1 to n is equal to n plus 1 over 2. Now we want to show that it's true for n plus 1. Since it's true for n, we can add n plus 1 to both sides. The reason for doing that is now on the left side, we have the sum from 1 to n plus 1, exactly what we wanted. On the right side, all you need to do is some algebra. For example, finding a common factor of n plus 1, and rearrange terms to find that the sum is n plus 1 times n plus 2 over 2. That's exactly the correct formula when it's n plus 1 instead of n. Then we're done. We have proven that this formula holds for all n by showing first that it holds for n equals 1, and then proving the inductive step. If it's true for n, then it's true for n plus 1.